Hello, everyone. Let's look at the 8.2 notes, and it's actually on arithmetic sequence. The general form is as shown. A of n equals A of 1 plus n minus 1 times d. Let's define what each of those things are. So A of 1 is the first term in the sequence. And d is the difference. Then n is the nth term in the sequence. It's whatever term you're wanting. Now, there's going to be a couple different forms, a couple different items. If you think about it, arithmetic sequences are, just by name of it, are addition items. Addition, subtraction, type of items. It is not multiplication. So let's look at this first example. Find the first 6 terms and the 200th term of 13, 7, and such. Well, we don't want to have to add up to the 200th term. That's why this general form really comes in handy. So let's look at this. Our A of 1 is our first term in the sequence. That's 13. And I need to find the D. We know that N is going to be 200 eventually. But what is the D? The D is going to be the difference. Remember, common difference. It's going to be the difference of these two. So sometimes it's addition, sometimes it's subtraction, and you can see that this is going down by -6 or subtracting 6. So my D is -6. Now we need to write a general form for this specific sequence. We have the overall general form for any type of sequences for addition or subtraction. So step 1. We're going to write the general form for this specific sequence. And hopefully you reviewed what a sequence is in the prior video. And what we take is we take this general form and we plug in our A of 1 and our D. Simple as that. So we have at any output, I have 13 plus, because that's my A of 1, n minus 1 times D. Well, D is -6. Then we have step 2. Let me try to slant this a little bit so you can see what I write. Step 2, we wanted the first 6 terms. Okay, so the first 6 terms are really easy to find. You could plug it into here, or you can just start and take -6 off of each one. They come out as 13, 7, 1, -5, -11, and -17, and it keeps going, but those are the first 6. The second part of the question is when this formula is going to actually come in handy. I don't want to continue to do the same method in step 2 where I just keep subtracting 6 for the next 200, but I need to find the 200th term. So to do that, I want the output. The A of n is what is that number, basically. So I want the 200th number. So A at 200, that is your output. That's what I'm trying to find. Equals 13 plus, well, it was n minus 1. If I want the 200th term, I want the prior number times -6. So that would be 199, because it's 200 minus 1, times -6. Now, order of operations, multiply before you add or subtract. and I would get a negative 1168. That is the number that sits in the 200th spot in the sequence. Now make sure you try it on your calculator yourself so that you can get it. Let's do example 2, and it indicates the 11th term of the arithmetic sequence is 52, and the 19th term is 92. What is the 1000th term? There's no way I'm going to want to add or subtract until I get to the 1000th. So let's start with step 1. And this type of item, I'm going to, again, write the specific general form. And I'm going to be using, so we're going to use the a of n equals a of 1 plus, this is adamantly imperative that you have the plus, it's not multiply, plus n minus 1 times d. All right, now I have two positions I need to find. I have the 11th term. I know the 11th term in the sequence is 52. I know the 19th term is 92. But I don't know the d, and I need to find the d. So before I can find the d, I need to set up these two equations. So at the 11th term, remember, equals 52. This is your input, and this is your output. So we will have my a of 11 equals a of 1 plus 11 minus 1 times d. Now remember that this item right here is your output. Well, we know what our output is. We don't know our d, and we don't know our a of 1, but at least I can fill that part in. Therefore, I have 52 equals a of 1 plus 10 times d. That much I know. Okay, let's go to the next piece I know. At 19th term, it's going to be 92. So again, I have a at 19 equals a of 1 plus 19 minus 1 times d. All right, again, I know that this is my output, and so is that one, and I plug it in. I have 92 equals a of 1 plus 18d. Now remember, I still have to find d, but look at my equations. Here we go. I have these two items. So I have two equations. We now need to find, so we need to find a of 1 and d by solving the system. This is a system of equations. It has two unknowns, just like x and y. I can use either matrices, or you can use your standard substitution or elimination. Personally, I'm going to use, my preference on this one is I'm going to use elimination. Let me push this up, make some more room here. Okay, so I take these two equations. I have, again, 52 equals a of 1 plus 10 times d, and I have 92 equals a of 1 plus 18d. Let's go ahead and I can eliminate these a's by making one negative. So I'll multiply this one by -1. This replaces by, then says negative 52 equals negative a of 1 minus 10 times d. This one stays the same, 92 equals a of 1 plus 18d. Elimination, they go head to head. Solve, I have 40 equals 8d, so d therefore equals 5. I needed my d. Let's go back to the original form. So the original form would be plugging in to this item up here, and I would take, or I should say up to one of these two. I'm going to pick the 52 because it's a smaller number. So 52 equals a of 1 plus 10 times 5. Remember, when we do elimination, we find one value and I plug it back into one of the two equations to find the other. This one becomes a of 1 equals 2. So now I not only know my d, I know my a of 1. So step 2 is to just plug in. So let's do step 2 is to plug in the values in the specific general form. Which, again, I'm only plugging back in my a of 1 and my d. That's what I needed originally. So I have a of n equals 2 plus n minus 1 times 5. I don't have to have parentheses around the 5. I just do for my own liking. And then the other question, now that I have my a and my first term and my difference, common difference, I can then answer the question of what is the 1,000th term. So step 3 is find the 1,000th term. And all I need to do is plug it in. So I have, what is the output at 1,000 if it is 2 plus 1,000 minus 1 times 5? Do your math. The output, or a of 1,000, is 4,997. That is your answer for the 1,000th term. Now we will continue on another video for the backside. So just a moment.